Alright, physics studies, this is another question from your workbook, page 222, question 15. It's a nice little lens question talking about a compound microscope that has two convex lenses. The question is set up, it tells you that you've got an object here. This is the objective lens, this is the eyepiece lens. It tells you that the object is 1.5 centimeters from the objective lens, and the focal distance of the objective lens is 1 centimeter, and the focal point of the eyepiece is 7 centimeters. So all of those are on there at this point. It's asking ultimately for the magnification. So it's asking, what is M? That's the question. And this is a bit of a tricky question. There's a lot of steps to this. We're going to analyze for the objective lens, and then we're going to analyze for the eyepiece lens. So first up, we probably want to draw ourselves a ray diagram. And again, it's complicated by the fact that there are two lenses, but we'll just do one at a time. And wherever this focal lens creates a focus, that will be essentially the object that the eyepiece lens is looking at. So in a sense, the terminology is going to change. We're going to create, the first lens will create an image, and then that image becomes the object for the second lens. So just watch for that change in terminology. All right, so straightforward lens drawing to begin with. We come in like this, we go through the focal point, and then we can do the same sort of thing with this one here. Actually, I should keep this as a straight line, not a dotted line. And then this one's going to go straight through the central piece of this lens. So we're creating an image, so round about here, and this is definitely not to scale. So please note that when you guys do this yourselves, you're going to be a bit more accurate. You're going to use a ruler, and it'll be a slightly different scale. But this is the image now that's produced from the objective lens, but it's going to become the object of the eyepiece lens. So just look out for that terminology. In fact, I'm going to put DI in red to represent the objective lens, but I'm now going to put DO for the eyepiece lens. So we'll just look for that change as we go through. Anyway, that's the first bit. The second bit then will be to treat this as now an object, and we're going to come through and analyze it with regards to the eye lens. So we're going to do exactly the same thing. We come into here, and this light is going to be refracted and sent through again, it's not straight, I apologize. It's going to go through the focal point of the eyepiece, and now we're going to just draw this backwards like this, okay, because it's going to create a virtual image, I think, and we can see that if we put this one through the central line here, you can see that they are actually, these two light rays are diverging, so they're never actually going to meet, but the image that you'll see is going to come from here. So they're going to cross at about this point. So this will be the image. So this is I'm going to label it on here, this is the DI of the eye lens. So you can see it's going to be much bigger. There's been a magnification from here to here. The question is, how much is that magnification? So let's just walk this through. We'll first of all analyze the objective lens, and hopefully we can take some values from the objective lens, bring them over into the eye lens, and that will give us the magnification power eventually. So what do we know? Well, we know the focal length is 1 centimeter. We know the distance to the object is 1.5, so DO is 1.5. And what else do we know? We know the height of the object. We know the height of the object simply by measuring it. So we were given a value, 2 divisions on your paper was equal to 1 centimeter, and this is approximately 1.5 divisions, so it ends up being 0.75 centimeters. So the height of the object, 0.75 centimeters. Okay, so there's a number of things we could work out. We've got F, we've got DO. Of course, we could work out DI. Okay, so we're not really sure what we need yet, but we can hopefully realize here that we can work out DI. Because if we just rearrange our lensmaker's formula, 1 over DI is going to be 1 over F minus 1 over DO. And you can very quickly plug in those values and work out that DI is 3 centimeters. And you can go ahead and just check your drawing too. Initially at the beginning of the question we're told that there's a gap here. The gap between the lenses is 6 centimeters, and actually this seems to make sense because the DI is about halfway between them, which would be 3 centimeters from my objective lens. So I'm pretty happy with that. Now I know my DI, looks like I could come in and work out the height of this image. Remember that we're talking about this red arrow being an image because it's been projected from the first lens. So in regards to the objective lens, this is an image. So I can now work out the height of this image because I have my HO, I have my DO, and now I have my DI. And we know that HI over HO is negative DI over DO, and we can just pretty much just plug these values in and work out that the HI is negative 1.5 centimeters. And again, it's worth just checking that everything seems to make sense. I would look back at my drawing and just check that that seems to be about right. It's definitely a negative because it's upside down, and I'd want to get my ruler out and just check that it's the right spacings. Remember that two squares on your drawing is 1 centimeter, so this should be 3 squares. So we should be checking that that is 3 divisions on your drawing. Okay. Let's move on and now look at the eye lens. So this now becomes the object. Okay, so we just have to relabel some things. We know the focal distance. We were told that at the beginning. That's 7 centimeters. We know the distance of the object. Well, this is the object, and it's halfway between. It's 3 centimeters away from this lens, which means it also has to be 3 centimeters away from the eye lens. Okay, does that make sense? Now, the other thing we know is the height of the object, because remember, this object, these two things are the same. The image becomes the object. So this is 1.5 centimeters. I'm just going to leave it as a positive for now because this is going to be hopefully doing some inversion as well. In fact, it's going to remain in the same orientation. I can see that from my drawing. So hopefully that's clear. I probably used the wrong colors here, but this image is from the first lens. The object is now regarding the second lens. Okay, so I've got focal length, distance to the object, height of the object. I ultimately want the height of the image, because then I'm going to compare the height of the image to this to give myself the magnification. So I'm looking for the height of the image. That's what I'm looking for. But to do that, I'm going to need the DI as well. I need a DI, a DO, and an HO, and that way I can solve for the missing HI. So again, pretty straightforward. I'm just going to use my lensmaker's formula to get DI, because 1 over DI is 1 over F minus 1 over DO. So I can solve for DI pretty straightforward by plugging these values in. Should get a DI to be negative 5.25 centimeters. And again, let's just double check that that's right. Distance to the image, 5.25 centimeters. Well, it's regarding this lens, and it's a negative because it's a virtual image, so it's going to be over here, and it's 5.25 centimeters, which is almost all the way to this lens, because remember this is 6, and so that looks about right. I'm pretty happy with that. I'm pretty happy with my height. I'm definitely happy with this. I think I know I'm right so far. Now it's a case of solving for HI, and of course I know that HI over HO is equal to negative DI over DO, and I've got to make sure that I keep my negative sign in there for DI. So this is going to end up being a positive value here, negative and negative. My DO, I'm going to keep that as a 3, and this 1.5 I'm going to get rid of the negative sign like I've done here, because these are in the same orientation. It's effectively not upside down because the image is starting upside down. Okay, so if you wanted to think about it as just being like this, okay, if you did it like this, this is your object is upright, your image is upright, so there's no need for that negative sign there. So that's kind of an important step, and maybe this caused a few problems here, but just think it through logically and you should get to that conclusion. Obviously we're then going to solve for HI, and your height of the image, you should get 2.625 centimeters, and now it's just a case of comparing. So let's just make some clear space here. The magnification is a ratio between this and the height of the object initially, which was 0.75. So I'm going to go, my ratio is 2.625 over 0.75. It's going to give me a magnification of 3.5. There's my answer. Alright, hopefully that makes a bit of sense. Think it through yourselves logically. If you have any questions about that, please ask me in class. But if you work it through step by step, looking at your diagram, checking each bit of your diagram to make sure that your values are all right, you should be good. Okay, thanks for watching.